Welcome to VINDAL'S concept. From wherever you are, I want us to look at this question, though I called it further mathematics. All maths is the same. There is no special maths called further maths. However, for the benefit of it. So this is one of the unusual equations we see. Sometimes we call it polynomial because this is 2 raised to power 2 is most of the things that students do in general mathematics in West Africa. But then it can go up to that. It can even go more than 6. But for now, how can we simplify this? Let's get started. At this point, I'm going to say that I'm going to factor these two. I'll factor these two. So I have t raised to power 4 bracket t raised to power 2 minus 1. Do you know what I did? I know that t raised to power 4 is in 6. Or let me show you what I did. What I did was t raised to power 4 times t raised to power 2 minus t raised to power 4 minus t raised to power 2 plus 1. So if you check very well, you realize that from here to here, that t raised to power 4 is here and t raised to power 4 is here. So I'm going to factor out t raised to power 4. So when I do that, I have that t raised to power 4 bracket. What is remaining here is t raised to power 2. Then minus t raised to power 4. T raised to power 4 is already out. So what is left is 1. That is how I got to this point. Now, between this and this, I'm going to bring it minus. I will put t raised to power 2 minus 1 all equal to 0. So what I did is I still left this the same way it is, because minus t times t raised to power 2 is going to give me minus t raised to power 2. The minus times minus is going to give me plus. What I did is to make sure that what is in this bracket must be the same thing in this bracket. So, but remember that 1 should be there. So in this case, let me factor out. I'm going to say t raised to power 4 minus 1 all bracket t raised to power 2 minus 1 equal to 0. That is what I have done. Now, remember this. T raised to power 4 minus 1 can be the same thing as saying t raised to power 2 bracket 2 minus 1 raised to power 2. Yes. I want to do it in terms of difference of 2 squares. So this one is separate. I have dealt with this one. Then we also have t raised to power 2 minus 1 raised to power 2. Right? So at this point, I'm going to apply difference of 2 squares. So difference of 2 squares is saying that if you have x raised to power 2 minus y raised to power 2, that is going to be x plus y bracket x minus y. So if I apply that here, I'm going to take 2 and 1. So I'm going to have t squared plus 1 bracket t squared minus 1. So then I have t squared minus 1 all equal to 0. Remember, this is just 2. I have made this to be this 2. Then this is still there. Now, if you also check very well, this and this can be opened in terms of difference of 2 squared. So I can still say that t squared plus 1, this one is going to be t plus 1, then bracket t minus 1. This is also going to be t plus 1, then bracket t minus 1, all equal to 0. So if this times this times this times this times this equal to 0, simply means that t squared plus 1 is equal to 0, or t plus 1 equal to 0, or t minus 1 equal to 0. That is this equal to 0. Yes, equal to 0. This equal to 0. And then I have done for this. I have done for this. I have done for this. So t plus 1 equal to 0 and or t minus 1 equal to 0. So if you check very well, this is going to be the fact that what is t, because we are solving for the value of t. If you check very well, t is going to be equal to plus or minus 1. For this one, t is going to be minus 1, or t is going to be 1, or minus 1, or 1. So in everything, for the sake of our curiosity, you realize that everything about t is going to be 1 or minus 1. Therefore, we say that t is equal to 1 or minus 1. That is the value of t. That means if I place the value of t to be 1 here, I will have 0. If I place the value of t here to be minus 1, I'm still going to have 0. That is the answer.